Hello everyone, this is Mary and I'm looking at the very last part of Module 2 notes of polynomials and rational expressions. We are going to be adding and subtracting rational expressions and doing complex rational expressions. I actually thought I finished these notes, but I just found out today I did not. So I apologize and I am getting them done tonight so that I can put them up so you can take a look at what you need to do. So adding and subtracting rational expressions. Basically what this means is you're going to be adding and subtracting fractions with polynomials in the numerator and denominator, or just in the denominator, or just in the numerator. So I just want to remind you that when you add and subtract fractions, you have to have the same denominator in order to do so. For example, if you have 3/6 plus 2/6. You can add these because you have the same denominator. Just go ahead and add the numerator, 3 plus 2, and you would have it over the same denominator, which gives us 5/6. If you're subtracting fractions, you still have the same denominator. So for example, I'm going to use the same exact fractions. If I have 3/6 minus 2/6, I can subtract those because I have the same denominator. So this is just going to be 3 minus 2 divided by 6, which gives me 1/6. So the same idea is going to come into play when we are doing this for rational expressions. The only thing is you have to have the same denominator, which means you may have to convert the denominators into the same polynomial expression. So let's start out with just adding and subtracting two rational expressions that have the same denominator. And I'm actually going to kind of cheat a little bit, and I'm going to add rational expressions that have the same, that are the same rational expressions for the first example, A and B, kind of like I did up here. I'm just going to do one this addition and one this subtraction, just like I did up here. So let's just start out. If we have two rational expressions where you have A divided by C and B divided by C, where C does not equal 0, because remember, you cannot have 0 in the denominator of anything that is a fraction or rational expressions. Rational expressions just means there are polynomials involved, and polynomials could be monomial, binomial, trinomial, and so forth. If I have A divided by C plus B divided by C, as long as the denominator is the same, we can just go ahead and add the numerator, A plus B divided by C. And same thing with subtraction. If I have A divided by C minus B divided by C, as long as the denominator is exactly the same, I can just go ahead and subtract the numerators, A minus B divided by C, as long as C does not equal 0. Now, if you can simplify further, you have to simplify further, like we were doing earlier with the multiplying and dividing of rational expressions, which is why we did that first before adding subtracting. If you cannot, that is fine, but just make sure that you cannot simplify any further. So example number 1, we're going to simplify the rational expression 4x plus 3 divided by x plus 5 plus x minus 6 divided by x plus 5. You will notice that each of these have the same denominator, which is a binomial x plus 5. Since they have the same binomial x plus 5, we're not multiplying the binomials. This is an addition. We're adding these two fractions. When we add fractions, we keep the denominator as long as it is the same. And I'm going to go ahead and put this in parentheses because you're going to need to with Luminome anyway, and you're going to need to with me, as just in case we can divide out any common factors. And then we're going to add the numerator. So we're going to have 4x plus 3 plus, and I'm putting this in, when you're adding, you don't really need to do this, but I'm just doing this anyway so you can see these are two different binomial terms, or they're actually factors, but we're going to be adding these. So when we're adding them, we don't have to do any distribution of signs, but when we subtract them, we're going to have to. So we could just go ahead and drop the parentheses and waste a little bit of ink here, but that's okay. We're going to add 4x plus x, and we're going to get 5x's. And we're going to do 3 minus 6, which gives us a negative 3. And that's going to be over x plus 5. The numerator belongs to each other. They are partners. The denominator belongs to each other. They are partners. They are separated by the division bar, which is kind of like, you look to see, can I divide anything out of the numerator that would make it so that I can simplify any further? But I can't divide out any numbers, and there are no variables here that I can divide anything out. So we are simplified as far as we can. We just have to look and say, what is the domain? Up here is c cannot equal 0. So it's the same thing. X plus 5 cannot equal 0. So we're looking at x cannot equal, well, domain. X plus 5 cannot equal 0. So if we subtract 5 from both sides, x cannot equal negative 5. So x cannot equal negative 5. Now, since we have the same denominator on both sides here, our domain is going to be the same for a and b. But now we're just going to be doing subtraction instead of addition. So our numerator should be different than over here in a. So I'm going to go ahead and I'm going to put parentheses around this because we are going to be subtracting our numerators. We have the same denominator. So we are going to keep the denominator. And we are going to subtract x minus 6 from 4x plus 3. And that you're subtracting the whole thing. That means you have to distribute this negative to the x and the negative to negative 6. Negative x, negative, negative 6. So minus x plus 6. So you've got 4x plus 3 minus x plus 6, all divided by x plus 5. Now we have to add like terms and we have to add constants. So like terms meaning with our variables and with our constants. So 4x minus x, that gives us 3x, 3 times x. Positive 3 and a positive 6 gives me a positive 9 divided by, and this is a partnership, so we have to bring that together. And we've got x plus 5. So now I know I can't factor anything out of here, but I have a 3 and a 9. They're both divisible by 3. And I have just a plain old x here, no variable here. So I can factor out a 3 from the numerator, and I get x plus 3. So 3 times x plus 3 divided by x plus 5. Now I look and say, can I divide out any factors from the numerator to the denominator? So x plus 3 and x plus 5 are different. I'm not allowed to divide out the x's, remember, because these are terms, they are not factors. You can only divide out factors. The x plus 3 is a couple, the x plus 5 is a couple. They're in some sort of partnership, whether it's a business, however, you can't divide them out. So this is our answer as long as x cannot equal -5. That's our domain. So our answer here is 3 times x plus 3 divided by x plus 5, as long as x cannot equal 5. You could also, this is fine, you can leave it in this order. Either way is fine, I don't care. This is okay, or this is okay. Luminome is going to allow you to write it either way. And this one over here is the 5x minus 3 divided by x plus 5. Put them in parentheses, folks. If you don't put them in parentheses, Luminome might not read them correctly because it's just a dumb computer. All right, so if you do not have the same denominator, you have to make the denominator the same. And in order to do that, you have to figure out what the least common denominator is. This is going to be the smallest polynomial that is a multiple of each denominator that in the rational expressions that are being added or subtracted. So if you are only adding and subtracting 2, then you only have to worry about a multiple of each of the 2 denominators. If you're adding or subtracting 3, then you have to worry about all 3 or 4 or 5 or however. So we're looking at that's a multiple of each denominator because you have to be able to divide each denominator into whatever the new denominator that you are creating is. So let's take a look at an example of a fraction would be. So if you have 2/3 plus 1/6 that you're adding together, you want to add those together. I can't add non-common denominators together. So I have to have the least common denominator. So I'm looking at these and I see, oh, I can divide 3 into 6. 6 is a multiple of, 3 is a multiple, excuse me, I was right the first time. 6 is a multiple of 3. So I'm going to look at that. I'm going to leave 6 alone because that's the smallest denominator where we have a multiple of both. So I'm just going to go ahead and I'm going to change the denominator of the 2/3. I have to multiply this by a 2. But if I'm going to multiply the denominator by a 2, I have to multiply the numerator by a 2. Okay? So I'm going to kind of extend that out. And my new addition will become 4, 2 times 2 is 4, 4/6 plus 1/6 and equals 5/6. So this right here is our 4/6. Our 2/3 is equal to 4/6 because we multiplied the denominator by 2 and the numerator by 2. So this is the concept that we're using, and we'll use it also for subtraction. You have to do the same thing for subtraction. I'm just going to show you an example for addition. We're going to find the least common denominator. So the first step would be to factor each denominator completely because we're dealing with polynomials. So when you're factoring, write the factor form and you use powers. For example, if you have x squared plus 4x plus 4, that's going to equal x plus 2 squared. And you're going to say, why is that? Well, that's because x squared plus 4x plus 4 is equal to, we factor it into 2 binomials, 2 factors of 4 that equal 4. So that's going to be x plus 2. When you add the 2 factors of 4, so 2 times 2 is 4, and 2 plus 2 is 4. Well, notice that these 2 factors are the same, so we can actually combine them. We can say this is really x plus 2, and we're multiplying it times itself twice. So it's in the same principle as saying x times x is equal to x squared. That's what we want to look at. So in order to do this, we already figured out writing everything out in factored form using powers. Then we list the common factors down for both of the, or more, if there's more than two. So all of the different denominators, we list the common factors. If the factors are common except for their power, we take the power, we take the factor with the highest power. Then we list the factors that are not common, and then I should have written, then we multiply them together. And we multiply just the factors. And we keep in factored form. Okay, so let's do an example. We're only going to find the least common denominator, the LCD of each expression. So the first one the first rational expression is 4 divided by 3x squared times y squared. And the second one is 5 divided by 6xy cubed. So the first denominator is 3x squared, y squared. The second denominator is 6xy cubed. So I'm going to factor these out. And when I factor them out, when you are listing common factors are basically saying if you have 3 and you have 9, 9 is equal to 3 squared. So I'm going to go ahead and say that 9 is 3 squared, and I'm going to take the 3 squared instead, okay? So that you can understand that. If you have x squared and you have x cubed, they're both x's, but I'm going to take the x cubed because that's the highest power. And I don't know what just happened to my light, but we'll see. Oh, there we go. Much better. All right, so this is going to be 3 times x squared times y squared. This is 3 times 2, this is the 6, times x times y to the third power. We've got the x variable, the y variable, we've got the x variable, the y variable, and we've got the number 3, and 6 is equal to 3 times 2. So let's just start with the numbers. We've got a 3, so we're going to take the 3. So we don't have to do the least common denominator is going to be 3 times something. We've taken care of the 3. We've got an x squared and we've got an x. So we're dealing with the variable x, but we're going to take the x squared, crossing out the x because we're taking the one with the highest exponent. We've got y's. We've got x squared and we've got y to the third power. I'm taking y to the third power and I'm crossing out the y squared because we're taking out the one to the highest exponent. And now I look at what's left. What's left is a 2. So I have to multiply it by a 2. So my least common denominator is going to be 3 times 2, which is 6. X squared y to the third power. Now we can go back over here and we can just say, but I'm looking at the numbers, 3 divides evenly into 6. Yes, it does. So when you're looking at numbers, you want to take the highest. If you're looking at just the numbers, you look at the highest number where all of the smaller numbers divide into. If that doesn't work, that's where it's good to go ahead and do the factorization, okay? So that's why I did this, so you could see why we were doing that. So our least common denominator is going to be 6x squared y to the third power. Now, if you have polynomials, such as x squared plus 4x plus 3 and x cubed plus 2x squared plus x. I'm not looking at the numerator. I don't care about the numerator. All I want to do is look at the denominator. So I'm going to write out the denominators. I have x squared plus 4x plus 3, and I've got x cubed plus 2x squared plus x. So to find the least common denominator, I have to factor. So I need two factors of 3 that add to 4. So that's going to give me two binomials that are x plus 3 and x plus 1. I know that I have a positive positive, so I have to have a positive positive. Once again, I have a positive positive, so I'm going to be factoring here. But I'm looking at each of these terms, and I can factor out an x. So I have a greatest common factor here, where I can factor out, I want to use a different color. I can factor out an x from each of these. And then I have an x squared plus 2x plus 1. So this is what I'm actually going to go ahead and do my factoring. So here, I have to keep my x, my greatest common factor, you don't lose it. I need two factors of 1 that are going to add to a positive 2. Well, that gives me a positive 1 and a positive 1. So x plus 1 times x plus 1. Well, we can rewrite this because I have two of the same factors. So this is going to be x, and it's going to be x plus 1 squared. So now I have my first polynomial is x plus 3 times x plus 1, and my second polynomial is x times x plus 1 squared. So I look and I say, what are the common factors? Well, my common factors are x plus 1 and x plus 1 squared. So I'm going to go ahead and circle that because I've got the x plus 1, but I'm going to take the one with the highest exponent. And I'm just crossing out the other one because now I look, I'm going to cross this off right now because this is the factor form that we're dealing with. So now I look, I have what's left. I have x plus 3, and I have an x. And if you're wondering why I crossed that out, it's because I want to deal with it in this form. So I factored, and then I simplified. Factored, factored, simplified. And then I'm taking what we need. So I'm going to bring the x out front, and I take what's left, which is the x plus 3. So the x and the x plus 3 are what's left, and my least common denominator is equal to x times x plus 1 squared times x plus 3. So we're going to use this idea for adding or subtracting rational extensions with unlike denominators. So we're going to be doing adding and subtracting. We're going to find the least common denominator. We'll rewrite each rational expression with the common denominator. We'll multiply out the numerator, but we're going to leave the denominator in factored form because we're going to have to add or subtract the rational expression, which means the numerator, in step number 2, and then we'll simplify the result if necessary, which means we might have to factor that, and then we might have to be able to divide out factors from top to bottom. So we're going to be taking everything that we learned in Module 2 from the beginning to the end for this particular information, okay? So that's what's happening here. So I've got a little bit of workspace in case I need to do any factoring. I am remembering that we are looking at having to do some, and this is also to help me with my least common denominator. So I'm just going to go ahead and write a little line. So I'm looking at 3 divided by n plus 2 plus 4 divided by n plus 2, n minus 2, I'm sorry, n minus 2 squared. So my least common denominator is going to be, they are basically the same factor, except for this one is to the second power. So my least common denominator is going to be n minus 2 squared. So what I have to do is I have to look at these, and I have to find, this one I'm going to leave alone because my denominator is okay. But this one right here has to be an n minus 2 squared. So what I have to do is I have to multiply the denominator by n minus 2, which means I have to multiply the numerator by n minus 2, only in the first expression, the first rational expression. So we're going to rewrite. So this is step number 1, we found the least common denominator. Step number 2, we're going to rewrite, and then we're going to multiply out the numerator, leaving the denominator. So step 2. So we're going to do 3 times n minus 2 over n minus 2 times n minus 2. And notice that n minus 2 divided by n minus 2 is 1. So we're really not changing the expression at all. And we're adding, and I'm going to write that over, n minus 2 divided by n minus 2 is equal to 1. So we're not changing the expression. We're adding 4 divided by n minus 2 squared. So I'm going to come over to here, and what this is I'm going to distribute, and this gives me 3n minus 6 divided by n minus 2 squared, and then we're adding 4, and that's divided by, again, n minus 2 squared. So now we have like bases. I distributed the numerator, I multiplied the denominator, and we're leaving it in factored form. Now step 3. We're going to add or subtract the rational expression that we found in step 2, but we're going to, now we have like denominators, we're just going to add or subtract the numerator. Since it's addition, we're going to just add straight across. So we've got 3n minus 6 plus 4. Now I know in the last page we put parentheses around, but with addition you really don't have to. And we have n minus 2 squared, and we're going to do step 4, which is, well, we're still doing step 3, I'm sorry. This is 3n, and this is minus 2. Minus 6 plus 4 is minus 2 over n minus 2 squared. And you can't factor out anything from there, so I'm just going to put my parentheses around this. This right here is my end result, but we have to find out what n cannot equal. Now, since they're both just n minus 2, you don't have to do it twice. Our domain is n minus 2 cannot equal 0, so n cannot equal 2. And that's our final answer. So that's step number 4, simplified completely. Okay, so here's B. We have x squared plus 9x divided by x squared plus 10x plus 24. And we're subtracting the rational expression 9 divided by x plus 6. So we're still going to have to do a little bit of work. We have to find our least common denominator. So I'm going to go ahead, I'm going to put a little bit of line here. And we're going to find our least common denominator, we have to do a little bit of factoring. So we have x squared plus 10x plus 24, and we have x plus 6. And I'm just going to put parentheses around x plus 6. So x squared plus 10x plus 24, we have two factors of 24 that add to 10. It's plus plus, so we have x plus 6 times x plus 4. So we look and we say, what do we have in common? What we have in common is x plus 6. I'm going to do a squiggly line. That's our first and that's our second. And we take what's left, it's x plus 4. So our least common denominator is x plus 6 times x plus 4. So this is what we had in common. They're identical, so you just take one, and then we take what's left, and that's x plus 4. So now, looking over here, we're going to leave this factor, so this is going to be x plus 6 times x plus 4. That's what it's going to be in the first denominator. The second denominator, we have to go ahead and I'm not going to keep writing step 1, step 2, step 3, but step 2, we have to go ahead and we have to change the second fraction into this equivalent rational expression, but with the least common denominator. So we have to look. So I have an x plus 6, but I don't have the x plus 4. So we have to multiply the denominator times x plus 4, which means we're going to multiply the numerator times x plus 4. So this is going to be step number 2. Step number 2 is going to be x squared plus 9x divided by x squared plus, we're going to have a factor. Sometimes I get ahead of myself. We've got x plus 6 times x plus 4, and we are subtracting 9, and I'm putting this in parentheses because we're going to be subtracting 9 times x plus 4 all over x plus 6 times x plus 4. So we have to distribute this negative 9 to the x and the negative 9 to the positive 4. So we've got x squared plus 9x minus 9x minus 36. 9 times 4 is 36, but remember we're distributing in the negative. And we're keeping one denominator. So this is going to be x plus 6 divided by x plus 4. So we now have the common denominator. And I'm looking where with step 3, we're just adding and subtracting, and we're going to be, we have a positive 9x and a negative 9x, and that becomes a 0. And so we have x squared minus 36 divided by x plus 6 times x plus 4. Well, if I look at the numerator, I can simplify this further. So in step number 4, it says simplify completely, simplify the result. Well, I can keep going. And this is the difference of two perfect squares, which we learned for factoring in module 2. So this is going to be x plus 6, square root of 36 is 6, and x minus 6. And the denominator x plus 6, x plus 4. Well, we can divide out like a factor. X plus 6 is a factor, x plus 6 is a factor. And we end up with our simplified expression, subtraction, is going to be x minus 6 divided by x plus 4. But we have to figure out what our domain is. And our domain, we have to look right here. We don't go all the way back up here, or we could, but we have to use both denominators. And we have to know that x plus 6 cannot equal 0, and x plus 4 cannot equal 0. So x cannot equal negative 6, and x cannot equal negative 4. So when we're looking at this expression, x minus 6 divided by x plus 4, x cannot equal negative 6 and negative 4. And it's very important that we call it, because we have to look up here. It's important because this can't have an undefined denominator and this can't have an undefined denominator. So you have to make sure that you call both of them. This one is the only, for the end, you would say minus 4, but we have to go back to the beginning. All right, so let's look at another one. And I like you to practice with subtraction, because subtraction is a little bit harder. And we're going to look at a little bit harder factoring. So we've got 3x plus 4 divided by 2x squared plus x minus 6. And we're subtracting x minus 1 divided by x squared plus 4x plus 4. You can work ahead, that's great. Working ahead, and you can check your answers as we're going. That it would be awesome. Otherwise, just keep working with me. So we've got workspace. We have to find our least common denominator. So for our least common denominator, we have our 2x squared plus x minus 6. Now this one, we already looked at this number, so I know that this is x plus 2 and x plus 2, which is really x plus 2 squared. So I'm just showing you that we don't even have to write this down over here, but I need to factor, and this is going to be factored by the AC method. So A is 2, B is 1, C is negative 6. So A times C is equal to 2 times negative 6, which is equal to negative 12. We need two factors of negative 12 that add to a positive 1, which would be 4 and negative 3, equal a negative positive 1. So we're going to have 2x squared plus 4x minus 3x. And this is factoring from module 2, so I'm not going to slow down, minus 6. I'm going to take the first 2 and the second 2, and I'm going to factor out the greatest common factor. So I can factor out a 2x, and I have left an x plus 2. And here I can factor out a negative 3. Always factor out a negative if you can, and I'll have an x plus 2. And that gives me a common binomial factor of x plus 2, and multiplied by 2x minus 3. So if I'm looking where I have an x plus 2 times a 2x minus 3 and an x plus 2 squared, I'm going to just draw a line here. My least common denominator is going to equal, we take the like factors, and I take the one with the highest exponents, which is going to be x plus 2 squared, and then I take what's left, which is 2x minus 3. So there's my least common denominator. Now while I'm at it, I'm going to go ahead and find my domain. Sometimes it's easier just to do it at the same time. So we have x plus 2. We have it all the way through, so x plus 2 cannot equal 0, so x cannot equal negative 2. 2x minus 3 cannot equal 0, so we're going to add 3, and divide by 2. So x cannot equal 3/2. If you can't remember how to do that, go back a little bit, and you'll be able to find that. It's just, I think, one video back. Okay, so there's our domain. There's our least common denominator. So right here, this is x plus 2 times 2x minus 3, and it does not matter what order that goes in. It could be 2x minus 3 times x plus 2. And this is x plus 2 squared, which is really x plus 2 times x plus 2. So you have to look and say, now we're going to have to convert both of these rational expressions. So you have to look and say, what do I need to multiply the numerator by in order to, this is step 2, what do I need to multiply the numerator by? So I'm going to go ahead and just rewrite. This is 3x plus 4. I'm going to put it in parentheses, divided by x plus 2 times 2x times 3. And we're going to be multiplying it times something. And then we're going to subtract x minus 1. And this is going to be x plus 2 squared. And we're going to multiply the numerator and the denominator by something. We just have to figure out what is missing. So this is x plus 2 squared. This is just x plus 2. And we've got 2x minus 3. Our least common denominator, 2x minus 3, x plus 2 squared. So I am missing one binomial factor of x plus 2. What I do in the denominator, I have to do in the numerator, because that's really, we're just multiplying it by 1 in the form of a fraction. For here, I have x plus 2 squared. I'm missing the factor of 2x minus 3. So once again, I'm just multiplying it by 1 in the form of a fraction. So now I have to keep the denominator, but I'm going to keep it, and I'm going to multiply the numerators out. So I have to multiply this out, this binomial times this binomial, and I have to multiply this binomial and this binomial out. But the thing is, this is a match set. I mean, this is a partnership, and this is a partnership. Whatever we multiply out here, you have to subtract every single term. So you're going to be changing the signs. And actually, if we want to do it, and I'm going to go ahead and do this. So I'm going to go and I'm going to erase this. So we're going to take back one step so that you can see it. We know what our denominator is going to be. So I'm just going to make one big old denominator here. Our denominator is going to be, and I'm going to bring the 2x minus 3 out front. It doesn't matter, but I am. And I'm going to do x plus 2 squared. I want to show you that we don't have to keep rewriting the same thing over again, because that just annoys me, and I'm sure it annoys you. We're going to be doing subtraction on top. So let's do our multiplication inside this set of brackets. 3x times 3x is 3x squared. 3x times 2 is a positive 6x. 4 times x is plus 4x, and 4 times 2 is a positive 8. Let's do this set of brackets. We've got 1 times 2x, which is 2x squared, x times negative 3, which is negative 3x, negative 1 times 2x, which is negative 2x, and we've got negative 1 times negative 3, which is a positive 3. So I'm trying to simplify this down a little more. So in this first set of brackets right here, we've got positive 6x and positive 4x, which is a positive 10x. In the second set of brackets right here, we've got a negative 3x and a negative 2x, which is a negative 5x. So instead of having to rewrite this over and over again, I'm just trying to simplify in some less steps. If you don't understand this, please let me know. You can Teams me or email me. So here we have a negative. We have to distribute this negative. So negative 2x. Negative 5x gives us a positive 5x. And a negative positive 3 is a negative 3. So we're continuing to simplify. I'm writing down the denominator. I am not multiplying the denominator out. Do not do that, okay? Leave it factored. So we've got 3x minus 2x squared, which gives me an x squared. We've got 10x minus a negative 5x plus 10x minus a negative 5x. This is why I have workspace. A negative is a positive. So this is right here. We've got plus 15x. We've got 8 minus 3. 8 minus 3. So that gives me a positive 5. All right, so before you do anything, you should always look at the numerator. It's at x squared plus 15x plus 5. See if you can factor anything out. There's no greatest common factor, there's no variables, no numbers. You look for 2 factors of 5 that will add to a 15. There are no 2 factors of 5 that will add to a 15, so the numerator is prime. So your answer is x squared plus 15x plus 5 divided by 2x minus 3 times x plus 2 squared, as long as x cannot equal negative 2 or 3/2. There's your answer. I cut it down because I didn't want to keep writing it down. Keep writing and writing and writing. Like denominators. If you're not sure, go back and rewind and to make sure that to check it again. All right, so let's now look at complex rational expressions. Complex rational expressions, 1 divided by m plus 3 divided by 5 divided by 1 divided by m plus 4 divided by 9, or 1 divided by m plus 3/5 over 1 divided by m plus 4/9. So what that is a fraction where you're adding a rational expression and you're dividing that by another rational expression, or where you could add or subtract. So it's messy, it looks messy. It's just a stacked fraction divided by a fraction, or rational expression divided by a rational expression. It looks really gross, but I want you guys to remember something. Here's my division bar. This divided by this. You can take and you can rewrite it as this in parentheses divided by this in parentheses. So I just want you to know that that's allowed. You're allowed to do that. It can make things a lot easier when you're doing your math. The first thing I always want you to do is find the least common denominator among all denominators in the complex rational expression. Multiply the numerator and denominator of the rational expression by the least common denominator found in step 1, and then simplify with division. And I almost always say write it out. Write it as a nice division where you are doing a division by a division, okay? So that's what I'm going to ask you guys to do. So let's go ahead and take a look at this. So here we go. First step, and I'm going to put a work spot. Least common denominator. We've got an M, we got a 5, and we've got a 9. We've got nothing in common. We've got an M, a 5, and 9. So we're just going to multiply everything together. So M times 5 times 9 gives us 45M. So what you're going to do is you're going to multiply everything by 45M. And all I'm going to say is, put this in parentheses and multiply this by 45M. Put this in parentheses, multiply by 45M. So you're going to distribute. You're going to distribute 45M to the first fraction, 45M to the second fraction in the numerator, 45M to the first fraction and 45M to the second fraction in the denominator. So, and I'll go ahead and do it the long way just so you can see this. So this becomes 45M divided by M plus 135M divided by 5 all divided by, okay, so I got that there. And then this one is going to be 145M divided by M plus we need to do 45 times 4. So this is 180M divided by 9. All right, so now this is kind of looking nice. We can divide out the M and the M. We can divide, oh, sorry, there should be an M there. My apologies. We can divide out the M and the M. We can divide this by 5. So if we divide this by 5, we're going to get 27. If we divide this by 9, we're going to go ahead and we're going to get 20. So we lose a fraction here. We're going to end up and get, for this particular one, we're going to get 45 plus 27M, all divided by 45 plus 20M. Now I look at this, you cannot, this numerator belongs together, the denominator belongs together. I keep saying that, but I keep having people who want to divide out the 45s or they want to divide out the M's. Oh, can't do that. What you can do is you can look and say, do we have any greatest common factor? I do. I can divide out 9, and then I get 5 plus 3M. In the bottom, I can divide out a 5, and I get 9 plus 4M. Now I look and say, do I have any like factors? 5 plus 3M is not the same as 9 plus 4M. So I am done. I'm going back to my original denominators, and the only one that I have to worry about is our M. So our domain, M cannot equal 0. So right here, m cannot equal 0. It doesn't matter what you end up with. Right now, we're just dealing with this one right here. Sorry about that. I just had some water. Okay, so now we're getting a little bit messier and a little bit more messy. So we still want to find the least common denominator. So let's go ahead and find the least common denominator. We have, if it helps, you can go ahead and put parentheses around those. But remember, here is your fraction bar, your main fraction bar. So we have x minus 3 divided by x plus 3 plus x minus 3 divided by x minus 4 divided by 1 plus x plus 3 divided by x minus 4. So our least common denominator, we have an x plus 3 in the denominator. We have an x minus 4. And we have an x minus 4. We don't have to worry about the 1. So our least we have, look at what's in common, and we take the x minus 4, and then we look at what's left. So right now, our least common denominator is going to be x minus 3 times x plus 3. Our domain x minus 4 cannot equal 0, so x cannot equal 4. And x plus 3 cannot equal 0, so x cannot equal negative 3. So there's our domain. Try to get out of the way as you're going, and it's helpful for complex rational expressions. So we're going to multiply both the numerator and the denominator individually. And since we have a fraction divided by a fraction and a fraction divided by a fraction, I want you to look at this and say, is there anything I can do to make this a little bit easier to see this? But for this moment, what you're going to be doing is it's just go ahead and multiply by the least common denominator in the numerator and the least common denominator in the denominator. And remember, you have to multiply the 1 by the least common denominator as well. You can't skip that. So we're going to do the least common denominator by each term, but I'm just going to go ahead and do it just once on each side. I'm going to do x minus 4 times x plus 3. Instead of rewriting it all over again, I'm going to try to make this more simple. And I'm going to say x minus 4 times x plus 3. And in order to help you guys see it a little bit better, I'm just going to do a little bit of a covering up, and I'm going to do the numerator, and then I'm going to do the denominator so it doesn't look so overwhelming. So here's the numerator, because it can be very overwhelming when you have all of these. We're going to multiply the numerator times the first term in the rational expression, and then times the second term in the rational expression. So when you're doing this, times the first term, the x plus 3's will divide out, and you're going to get x minus 3 times x plus 4. x plus 3's will divide out, and you're going to get, and I'm going to come down here, and you're going to get x minus 3 times x minus 4. I'm going to come back up. This is addition. So now let's go to the second term. If you multiply here, you're going to get x minus 4 and x minus 4 dividing out, and then you're going to get x minus 3 times x plus 3. And once again, it's addition. Okay, so that was the numerator. So we're simplifying the numerator. I'm going to draw my division bar, and now I'm going to look at the denominator. So here's the denominator. I'm going to go ahead and I am going to multiply the least common denominator times 1 and the least common denominator times the x plus 3 times the x minus 4. Now remember, for this one, it's also addition. So we've got x minus 4 times x plus 3. And then we have x minus 4 and the x minus 4 dividing out. And you're just going to have x plus 3 times the x plus 3. So sometimes this will help if you use a little bit of paper to cover things up. Now we have addition, so I don't really have to worry about distributing any negatives. You can put big brackets around here and brackets around here. And now that I don't have to worry about distributing any negatives, I'm just going to go ahead and do the multiplication. So I've got x times x is x squared minus 4x minus 3x. Negative, negative gives me a positive, and 3 times 4 is 12. Plus x times x is x squared. We've got a positive 3x, and we've got a negative 3x, and we've got a negative 9. And here, let's go to the denominator. We've got x times x, which is x squared. We've got a positive 3x. We've got a negative 4x. And we've got a negative 12. We've got a positive x squared, a positive 3x, and positive 3x, and a positive 9. These are not the same. You've got a negative right here, so you have to deal with negatives in the numerator. Now I'm going to look and see what are my like terms. I can't just cancel terms. I have to have factors. And since this was an addition right here, I can't cancel up here either because I have this factor plus this factor. I have to have all factors. So let's go ahead and add like terms. I've got an x squared and an x squared. So that gives me 2x squared in the numerator. I've got a positive 3x and a negative 3x. And I have a negative 4x and a negative 3x, so that gives me a negative 7x. I have a positive 12 and a negative 9, so that gives me a positive 3. I have an x squared and an x squared, which gives me a 2x squared. I have 3x, 3x, and 3x, and a negative 4x. So 3 and 3 and 3 is 9, minus 4, which is going to give me a positive 5x. And I have a negative 12 and a positive 9, which gives me a negative 3. So my numerator is 2x squared minus 7x plus 3, and my denominator is 2x squared plus 5x minus 3. So while we had a lot of the same looking binomials, we ended up with a completely different numerator. and denominator. So what we want to do is we want to factor in order to see if we can, first of all, we want to see if we can factor, and then we want to look and see if we can factor into binomial factors where we can divide out. So I'm going to go ahead and do my 2x squared minus 7x plus 3. I have a and c. So a times c is equal to 2 times 3. That equals 6. Two factors of 6 that equal a negative 7 are negative 6 and a negative 1. So 2x squared minus 6x minus 1x plus 3. I'm going to take the first 2 and the second 2. I can factor out a 2x from the first 2 grouping, and I'll have an x minus 3. I have a negative 1, so I'm going to factor out a negative 1, and that will give me an x minus 3 when I factor out from the second 2. So I have an x minus 3, and then I have the 2x minus 1 left, so 2x minus 1. That's for my numerator. All right, so 2x squared plus 5x minus 3. My a and my c are 2 times negative 3, which is negative 6. I need 2 factors of negative 6 that equal a positive 5. Well, that would be a positive 6 and a negative 1. Excuse me. So 2x squared plus 6x minus 1x minus 3. It looks a little bit alike, but it's not quite. So I can factor out a 2x from my first grouping of 2, and I get an x plus 3. And for my second grouping, I can factor out again a negative 1, and I get an x plus 3. So I have an x, excuse me. All right, I can factor out an x plus 3 and an x plus a 2x minus 1. Well, I have common factors from the numerator and denominator, 2x minus 1 divided by 2x minus 1. And I end up with an x minus 3 divided by x plus 3 is my simplification of this complex gobbledygook right there, as long as x does not equal 4 and negative 3. So we're getting down to the end. Seems to be closer. We just have a couple more examples, and these examples I'm going to go ahead and give you the least common denominator. We have our complex fractions divided by our rational expression divided by our rational expression, or actually it's just divided by h. So that's what makes it a complex rational expression. And remember, the h is h over 1, so that's why I just wrote that in. And I'm going to go ahead and tell you what the least common denominator is for this. If you're finding it, you're looking at each of the fractions, and the fractions are h plus a plus h, a, and 1. So our least common denominator is just going to be a times a plus h. We don't have to worry. Oh, and I'm sorry. It's going to be h times a or ah times a plus h, because you have to deal with all of them. So our least common denominator is The whole thing. No. I'm sorry. We don't need the h because our denominator is 1, a plus h, and a. So it's just a times a plus h. I'm trying to rush a little bit here to make it a little bit shorter, and that's not helping me. So we're going to multiply each of the numerator and denominator by a times a plus h. Don't rush, even if it makes things too long. Whenever I rush, it doesn't help me out. So I'm going to multiply this monomial times a binomial times each of the two sides of my complex rational expression, and the numerator and the denominator. So this rational expression, and this just plain old fraction, okay? So now I'm going to end up with the a plus h divides out here, and I'm just going to get 4a minus, and the a divides out here, and I'm going to get 4 times a plus h, all divided by, so there's my numerator, and in my denominator, since 1 is the denominator of the rational expression, the complex rational expression, since the denominator is 1, we're just going to multiply the numerator times everything. And this is going to be a times h times a plus h. I'm bringing the a out front because that's a is in the first letter of the alphabet. Okay. So now I have to distribute here, and I'm going to get 4a minus 4a plus 4h, all divided by a times h times a plus h. Now 4a minus 4a gives us a 0. And so we end up getting 4h all divided by a times h times a plus h in parentheses. Well, now I'm looking to say, can I divide out any like terms from the numerator and denominator? Well, this is multiplication, so these are factors. This is multiplication, factor times factor times factor. So I can divide out the h's. And so now I have 4 times a plus h. Now, normally I tell you to worry about the domain here, but this would be one of the questions where I tell you not to worry about the domain, because if you look at this right here, you would have to worry about a plus h cannot equal 0, which would mean a cannot equal negative h, and that gets a little bit complicated. So this is one that I would tell you not to worry about finding the domain. So your answer is 4 divided by a plus h. I'm going to tell you not to worry about finding the domain on the next one, although the domain would be fairly simple to find out on this one. I'm just going to say, don't worry about it. But we have to find the least common denominator. So in finding the least common denominator, we actually have to look at the denominators on all of these. So we have b squared minus 25. This is for finding the least common denominator. We have b plus 5, and we have b minus 5. Well, b squared minus 25 is the difference of two perfect squares. So it's b plus 5 times b minus 5. Well, if we are looking at what's in common, we can look at what's common between all three, just two. So we have a b plus 5 between two of them. So we're going to take the b plus 5. And we have the b minus 5, which is in common between two of them. So we're going to take the b minus 5. And if we look at that, that's actually our b squared minus 25. So our least common denominator, we're going to leave factored, but our least common denominator is b plus 5 times b minus 5. So we're going to multiply the numerator and the denominator by b plus 5 times b minus 5, knowing that b squared minus 25 is equal to b plus 5 times b minus 5. Keep in knowledge that this equals this factor. So I'm going to look at just the numerator first, and once again, you need to have the paper to make this a little bit easier. And I think I'll just fold it up a little bit so it's not so overwhelming. So b squared divided by b squared minus 25 minus b divided by b plus 5. If I multiply that whole thing by b plus 5 times b minus 5, we're going to do the distribution. And this is going to equal the b plus 5 times b minus 5 divide out the first side of this for the first rational expression. And you divide out, and you just get b squared. And we're going to subtract. And for the second rational expression, b plus 5 and b plus 5, where you can divide those out. And you're going to have b times b minus 5. And that's the new numerator. Now for the denominator, we're looking at doing the same thing. We've got b divided by b squared minus 25 minus 1 divided by b minus 5. And you're multiplying it by b plus 5 times b minus 5. Well, the b plus 5 times b minus 5 is our b squared minus 25. We're going to multiply by that by the first rational expression. And the b plus 5 times b minus 5 divides out with the b squared minus 25, and you're just going to get plain old b. Subtracting, and we look over here, we can divide out the b minus 5 and the b minus 5, so we're going to be subtracting 1. And that's going to be in our denominator now. So we have to multiply out the numerator, and we're going to have b squared minus b squared, and minus minus gives me a positive 5b. And that's all over b minus 1. Well, when we have a negative b times negative b is the way I get the positive b, 5b. Well, a b squared minus a b squared gives us a 0. So our answer is going to be 5b divided by b minus 1. That's not a 6, that's a b. But I'm putting that in parentheses for lumen ohm. And there you go. Now, if you wanted to really quickly the domain, if you have to look at each one of these, so this would have been b plus 5 and b minus 5. So the domain is going to be b cannot equal 5 or negative 5. I know I didn't tell you, I told you not to worry about it, but we just did it. And the very last page on video, but we're almost done. Once again, rewind if you've got a problem, or you can Teams me. Simplify the complex rational expression. Well, complex means that we've got a fraction divided by a fraction, right? Well, this is 1 minus x to the negative 1 minus 6x to the negative 2, all divided by 1 minus 1 minus 9 times x to the negative 2. Well, that doesn't look like a fraction divided by a fraction, but it really is in disguise because we don't want negative exponents in our polynomials. We're not really allowed to have exponents in our polynomials. And we're really not supposed to have variables in our denominators, but what we're going to do is we're going to rewrite this. So get rid of the negative exponents first. So this is going to be 1 minus, and really x to the negative 1 is 1 over x to the first. And minus 6 times x to the negative 2 would be 6 times 1 over x squared, which would be 6 divided by x to the second power. Well, now you're starting to see the complex rational expression. And 1 minus 9 times x to the negative 2 is 1 minus 9 times 1 over x to the second power, which is 9 divided by x to the second power. Well, we don't want fractions in the denominator, or we don't want variables in the denominator. We don't want this to be a complex rational expression. So we want to get rid of our fraction over the fraction. We want to just make it one nice basic fraction. So what we're going to do is we're going to multiply by the least common denominator. And the least common denominator, if you look at here, we're just looking at regular variables. Our least common denominator is going to be x squared. So we've got a trinomial in the numerator. We're going to multiply every term by x squared. We've got a binomial in the denominator. We're going to multiply every term by x squared. And really, once again, we're just basically multiplying by 1. So we have to distribute, and we're going to distribute. All right, so if we do that, 1 times x squared is x squared. X squared times 1 over x is x squared divided by x, which is really, we're just subtracting x. We're subtracting 6 divided by x squared times x squared. And if it helps, I'll just do my handy dandy this. So 6x squared divided by x squared is just really 6. So I'm subtracting 6. There's my numerator now, because I just multiplied it all by the least common denominator. Well, let's do that in the denominator. So I'm going to multiply everything by x squared. So x squared times 1 is x squared. And now I'm going to do 9 divided by x squared times x squared. The x squareds divide out, and I'm subtracting 9. Well, now we just have a beautiful polynomial divided by a binomial, and we're just going to factor, and we're going to factor. And then we're going to divide out like factors if there are any. So let's look at here, and this, we have 2 factors of -6 that add to -1. Well, it's got to be a plus and a minus, because in order to get a negative number here, it has to be a plus and a minus. So we want a 2 and a 3, but it's going to be a negative number, so 3 has got to be the negative. So x squared minus 3x plus x, negative 3, and the positive 2 give me a negative 1. And a positive 2 times negative 3 give me a negative 6. The x squared minus 9 is the difference of two perfect squares. So we've got x times x is x squared, and a plus 3 and a minus 3 give us our negative 9. So x plus 2 divided by x minus 3, x plus 3 divided by, x plus 2 times x minus 3, all divided by x plus 3 times x minus 3. And so we can divide out our x minus 3s, because that really gives us 1. And we've got x plus 2 divided by x plus 3. Put it in parentheses for lumen-ohm. And there you go. There's the simplified complex rational expression. Last problem. Yay! And please forgive me for stumbling over some words. It's been a long day, and I am fighting off a cold. So once again, we have negative exponents. We don't want the negative exponents. So 64 y to the negative third plus x to the negative third divided by 4x to the negative 2 y to the negative 3 plus x to the negative 3 y to the negative 2. Let's create a complex rational expression with only positive exponents. So this right here, we've got a negative exponent denominator. So 64 divided by y to the third plus 1 over x to the third. Here we have 4. These are both negative, so they're both going in the denominator. X squared y to the third power. And we're adding, they're both negative, so 1 over x to the third, y to the second power. Okay, so least common denominator. We only have variables. We've got y to the third, we've got x to the third, we've got x to the second, y to the third, and we've got x to the third, y to the second. Well, we have to look. We want the variable to the highest exponent. So we're looking at y to the third. We've got x to the third. We're going to multiply those together. Now let's look at the other two right here. X squared y to the third. All right, we got both of those variables. That eclipses this one because this has got an x to the second, but we've got an x to the third. X to the third, y to the second. This has got a y to the third, this has got a y to the second. So this is eclipses both of those because when we multiply this together, this will divide into this. This will divide into this. And both of these will divide into this. So our least common denominator is y cubed, x cubed. So we're going to multiply each, the numerator and the denominator, by x cubed, y cubed. And I'm just going to cover up the denominator. So if we multiply 64 divided by y cubed plus 1 divided by x cubed, if you look at the first term, the y cubes divide out, and you've got the y cubes divide out, and you've got 64 x to the third power. Plus, if you look at the second term, the x cubes divide out, and you just have y to the third power. If you look at the denominator, now we have to write a denominator division bar, because this is where our complex rational expression goes down in just to a polynomial division. So now we've got 4. Our y cubes divide out, and x cubed divided by x squared gives us an x plus. Right here we've got a 1. So this is x cubed y cubed divided by x cubed y squared. So the x cubes divide out. And we've got y cubed divided by y squared. So we just get a y. So this is going to be 64 x cubed plus y cubed divided by 4x plus y. This belongs together. It's in the denominator together. It's a binomial. It belongs together. It's a binomial factor. And now you got to look at the numerator and say, can we factor this any further? All right. Perfect cube, perfect cube, perfect cube. So this is the sum of 2 cubes. Well, the sum of 2 cubes is a formula. Let's remember that the sum of 2 cubes, a cubed plus b cubed, is equal to a plus b in parentheses times a squared minus ab plus b squared. It's a formula. So in order to find a, that is equal to the cube root of the first part of the top binomial. So that's going to be the cube root of 64 x to the third power. B is going to equal the cube root of y to the third power. Then we're going to have to find out what a squared is. We're going to have to find out what b squared is, and then we're going to find out what ab is. These are all just plain old fill in the blank for your formulas. So a is equal to the cube root of 64, which is 4. Cube root of x cubed is x. B is the cube root of y, which is y. A squared is 4x times 4x, which is 16x squared. B squared is y times y, which is y squared. And AB is 4x times y, well, which is 4x times y. So there it is. So let's fit it into the formula. I should have probably given a little bit more room. So here we go. Oops. So this is going to be 4x plus y. I'm just fitting it in. A, B. A squared is just 16x squared. I'm subtracting AB. AB is 4x times y. And I'm adding b squared, which is just y squared. Folks, if you've got variables and you've got numbers, you're going to have variables and numbers in your ending answer. A squared plus b squared is a binomial times a trinomial. A squared, a cubed minus b cubed is a binomial times a trinomial. They are both formulas. So let's rewrite this. So this is 4x plus y times 16 squared minus 4xy plus y squared, all divided by 4x plus y. Well, I look at this and I see that in the numerator I have 4x plus y. In the denominator I have 4x plus y. They are both binomial factors that are the same. So my final answer for this kind of ugly looking thing, which turns into an even uglier looking fraction, is just going to be 16, oops, I forgot, x, my apologies, 16x squared minus 4xy plus y squared. And boom, we are done with Module 2 with the video that somehow got lost. So thank you, and I'm looking forward to more videos. And sorry this is so freaking long, but thank you for tuning in to Professor Mary's math videos. I'll see you soon. Bye.